Hey, today we're going to talk about 3.6 age structure diagrams. Before we begin, you can check out the Enduring Understanding and the Learning Objective. Pause the video, review the essential knowledge, and set up your Cornell notes. So, an age structure diagram is basically something to show graphically the population breakdowns within, or the breakdowns within a population based on the ages. And the most common age structure diagram that we will use is a population pyramid. So I'm going to show you using population pyramids in this lesson. So we have one type of population pyramid, and there is a lot of information here. So I'm just going to kind of walk through this with you. Typically, you're going to have different ages in the middle, and these are the cohorts. In other words, this is birth, this is age 5, 10, 15, 20, and going up to 75 plus. Sometimes they might go up to 85 or higher. Sometimes there might be a plus there, depends on, but 99% of the time they're going to be in 5-year increments. So the way that I have designed these is this is at 0, this is 5, and 10, 15, 20, and so on. The males are going to be on the left, the females are going to be on the right. And typically you will have the population percentage on the bottom as opposed to the actual population, because if you had the actual population, it's not going to be really representative, because if you had a population, for example, like of India that has over 1 billion people, and the population of Sweden, which has a much smaller population, you might not get, it won't be comparing the same, it won't have the same look to it. So we also have 3 major groups. We have pre-reproductive, and these are humans that basically are not of reproductive age, typically under age 15. We have reproductive, in other words, this is the age of people that can be reproducing between 15 and 45. And typically after 45, this is just considered post-reproductive. Yes, it is possible for some women to give birth until 50 or even later. Men can give birth until they're dead. Men don't go through anything like menopause. The sperm will slow down, and you might be affecting your sperm production as you age. But typically, it's just a grouping based on average years, and also younger children under 15 can definitely have children as well. Now, when we look at a graph like this, we want to pay attention to where the pre-reproductive populations are in comparison to the other groups. If the amount of pre-reproductive individuals is much larger than the reproductive and the post-reproductive, this is going to have rapid growth. So if the base is wider, it is showing rapid growth, because as these pre-reproductive individuals grow to be reproductive age, then they're going to start having babies, so it will widen the base even more if they continue to reproduce at this rate. Okay, so here's an example of a question you might encounter. The total population is 50 million people. What is the population of pre-reproductive males? So what you're going to do is you're going to make a proportion where you have percent over 100 equals part over whole. If I got a 75% on a test and the test was 30 questions, I take 70 over 100 equals X over 30. So you'd figure out if I got a 70 on a test that had 30 questions, do the math, figure out what is the number of questions I got correct. Okay? Anyway, you can use this proportion to solve a lot of these percentage problems. Now, I know my whole population is 50 million. I don't know the part, which part is pre-reproductive. I don't know that actual value. But what I can figure out is I can figure out the percentage. I do know that I have, in pre-reproductive, I have 3 different groups. I have 9% are under 5 years old. I have 8% roughly are between 5 and 10, and roughly 7% are between 10 and 15. So I'm going to set up my proportion right now. 9 plus 8 plus 7 over 100 equals x over 50 million. When I add those numbers up, I get 24 over 100 equals x over 50 million. When I solve for x, the answer is 12 million males. Do the math on your calculator. You'll see it right there. Okay. So again, what I want to do is I want to be adding up. If I tell a group I want to add up each of these, and I only want to add up for one side if it's talking about males. If it's talking about all pre-reproductive, I'd have to add up all the male and all the female as well. So when you have a population that is exhibiting slow growth, the base of the population pyramid is going to be a lot closer in size to the reproductive. So the pre-reproductive group is only going to be slightly larger than the reproductive group, which will be slightly larger than the post-reproductive group. So again, the very wide base is rapid growth. As you get more narrow, you will have slow growth. But since the base is still wider than the other portions, it is definitely still growing. Now when you have zero growth, it doesn't matter what's happening up here because they are not reproducing anymore. In this population, there's a lot of older individuals that are surviving. But if you notice here, when I have zero growth, the pre-reproductive and the reproductive are relatively the same. So even though it might go in and out just a little bit, it's pretty much even, and it's pretty much the same percentages. So this is showing zero growth. And finally, the last one is I have negative growth. And negative growth is when I have a larger population that is reproductive than is pre-reproductive. And when the bottom is narrower and it kind of bulges out in the middle, again, that shows negative growth. So I would go back, if you need to go back and sketch each one of these out. You do not need to sketch out each individual box, because that is not as important. The overall shape is far more important. Okay? For example, like this in the FRQ. So in this FRQ practice, I would like you to explain which country to the left has the slowest population growth rate. I look forward to seeing your responses. I thank you for your attention. I hope that this was informative, and I will see you soon.